worthy one. Today we are going to explore something fascinating, the Collatz Conjecture, but applied to negative numbers. As you know, the Collatz Conjecture is one of the most famous unsolved problems in mathematics. It is simple to state, but incredibly difficult to prove. Most people study it on positive integer, but today we are going to look at what happens when we extend this problem to negative domains. We'll explore two domains, the standard 3n+1 and a modified version 3n-1, and compute their behavior in negative integers. So, the standard Collatz rule for any integer n, if n is even, then the result is n over 2. If n is odd, then the result is 3n+1. On positive integer, every sequence reaches 1. What about negative integers? No longer reach 1. Instead, enter negative cycles. Different starting values give different cycles. Two variation, 3n+1 versus 3n-1 with the negative integer numbers. The key question is what happens when we apply the Collatz map to negative integers? This is the main question that we will investigate it. The negative cycles with 3n+1. If n is even, then the result is n over 2. If n is odd, then 3n+1. Discover the negative cycles. Here you can see the starting value -1. The cycle is -1, -2, -1. And the cycle length is 2. The cycle is -1, -2. If the starting value is -5, then based on the rules 3n+1, we have -5, -14, -7, -20, -10, and finally -5. Also, it has cycle, and the cycle length is 5. For -17, the result is, because we should compute the numbers based on the rules, -55, -164, and so on, and finally leads to -15. The length of cycle is 18. The key observation, every negative integer under 3n+1 eventually enter one of these cycles. No value gets step to infinity. For other values also we enter to one of these cycles. Here we can see that step by step 3n+1 on n equals to -1. Each step, if the n is -1, then -1 is off. Then 3 multiplying -1 plus 1 is -2. So after the -1, it's entered to -2. -2 is even. Then -2 over 2 is equal to -1. Then again, enter to -1. And -1 also is odd. Then enter the related to -1 for coming into cycle. Here also we can see the cycle. -1, -2, -1, and then goes to -2. For n equals to -5. Let's start from -5. The value is -5 is the first step. -5 is odd. Then the result, if we apply the rule 3n+1, the result is -14. So we enter to the -14. -14 is even. Then -14 divided by 2 is equals to -7. Enter to -7. -7 is odd. Then the result is -20. Enter to -20. And finally, -20 is even. Then enter to -10. -10 is even. Then enter to -5. So here for -5 we have cycle. We have a cycle with 5 steps. In next is that we investigate 3n minus 1 with the negative cycle. The rule is if n is even, then the result is n over 2. If n is odd, then the result is 3n minus 1. Here we can discover the negative cycle. If I start with minus 1, the cycle is minus 1, minus 4, minus 2, and minus 1. The cycle length is 3, minus 1, minus 4, and minus 2. If I start with minus 7, then we have a cycle length for minus 5, minus 16, minus 8, minus 4, minus 2, and then minus 1. After the minus 1, then join to the above the cycle length 3. If I start with minus 7, goes the sequence and then go to the cycle, go to the above sequence, and then finally go to a cycle with length 3. So the observation here that 3 and minus 1 map often lead to the same 3 cycle, minus 1, minus 4, minus 2, and minus 1. This is the analog of reaching 1 in the positive case. All here we can see the step by step for 3 and minus 1 on n minus 1. If n is minus 1 and minus 1 is odd, then the result is 3 multiplying minus 1 is equal to minus 4. Minus 4 is even, then minus 4 divided by 2 is minus 2. Minus 2 is even, then the result is minus 1. With that to minus 1, forming a 3 cycle. Here we can see the cycle with 3 steps. For n is equals to minus 5. Then here we can see the value is odd. Then after applying the rule, the result is minus 16. Here we can see enter to minus 16 state. Minus 16 is even. Then the result is minus 8, goes to minus 8. Minus 8 is even, go to minus 4. Minus 4 is even, then goes to minus 2. And minus 2 is even, then go to minus 1. Minus 1 is odd. Then join the 3 cycle. Here we can see the behavior of 3 and minus 1 for n equals to minus 5. After these states, go to this cycle, a 3 cycle. And here we have the comparison between 3n plus 1 and 3n minus 1 on negative number. Starting with value minus 1. 3n plus 1 create a 2 cycle for minus 1. For minus 5, create a 5 cycle. But 3n minus 1 create 3 cycle. For minus 1, 3n plus 1 create 2 cycle, enter to 2 cycle, and 3n minus 1 enter to a 3 cycle. Minus 5 enter to the 5 cycle. Here goes to the sequence and then enter to 3 cycle. For minus 7, same as 5 cycle. It goes to the sequence. But for 3 and minus 1, after the sequence, goes to 3 cycle. So the behavior is different. 3n plus 1 create multiple distinct cycles. 3n minus 1 almost always leads to a single 3 cycle. Both are bounded divergence. They are converged, but with the cycle. Symmetry with positive case. Here 3n plus 1 on negatives approximately equal to 3n minus 1 on positive. They have the mirror behavior. And although we have a visual comparison between the 3n plus 1 and 3n minus 1. 3n plus 1, we have a 2 cycle, but 3n minus 1, we have 3 cycle. Minus 1, minus 2, minus 4. But here the 3n plus 1 would have 2 cycle, minus 1, minus 2. The 3n minus 1 maps on negative integer behave like a reverse of the 3n plus 1 map on positive integer. The behavior of 3n minus 1 on negative integer or like the 3n plus 1 on positive integer. Here also we can see that 3n-1 on n larger than 0. Symmetry was 3n+1 on positive integers. Also, we have some comparison between 3n+1 and 3n-1, the property of 3n+1, positive domain. 3n+1 converts to 1. 3n-1 diverges or created cycles for positive domain. For negative domain, 3n+1 create multiple cycles, 2, 5, 18, and so on. But 3n-1 converts to 3 cycles, and 3 is a subcycle. Yes, the cycle length in 3n+1 is 2, 5, 18, but in 3n-1, the cycle length is 3. Number of cycles to 3n+1, the number of cycles in infinite is only conjecture. But 3n-1 is finite, only one cycle. The behavior in 3n+1 is chaotic and unpredictable for the generated sequences. But 3n-1 most structured and predictable. The symmetry for 3n+1 is antisymmetric with 3n-1, and 3n-1 antisymmetric with 3n+1. Also here we would have the finding 3n+1 on negative integer is symmetry with 3n-1 on positive integer. This symmetry means that starting one gives insight into others. This is important notes that we can study behavior of one of them precede behavior of other. Also here we have the behavioral comparison. 3n+1 value fluctuate more widely. 3n-1 value follow a more regular pattern, but ultimately bounded. Different number of attractors. The number of attractors 3n+1 and 3n-1 are different. 3n+1 cycle length is starting for n equals to -17. The 3n+1, the cycle length is 18. Also here the sequence of the cycles. 3n-1 path to 3 cycle. After this sequence, enter to a 3 cycle, -1, -2, and -1. Also here is the trajectory comparison for n equals to -5. We can see that curve with 3n+1 and 3n-1. After the sequence, it's entered to a cycle. For the green graph, here is the cycle. Here it is the cycle. Here is the cycle. And for the red curve, after the sequence, it also enters a cycle. We have here a cycle. 3n+1 create a 5 cycle, and green the 3n-1 enter a 3 cycle. Here is the value, and here the number of steps. Also here is the curve for n equals to -7. We can see the behavior of 3n+1 and 3n-1 for n equals to -7. For 3n+1, enter the 5 cycles. 5 cycles with 5 steps. Here also we can see the cycle. And 3n-1 take a longer but leads to 3 cycle. After some fluctuation, leads to a 3 cycle. Also in this graph we can see the cycle length distribution for different value, for different starting value. The starting value from -1 to -20. The cycle length, we can see that the cycle length also grows. Some parts are similar, but some parts are not similar. 3n+1 show cluster cycle lengths. The 3n-1 show more variation. You can see here the green curve that has more variations. And also the phase space comparison. that 3n-1 only goes enters to 3 cycle, but 3n+1 for negative values goes to 3 cycle. The first one is 2 cycles, second one is 5 cycle, and third one is 18 cycle. 3n+1 has multiple bases of attraction, while 3n-1 has a single base in that all negative number eventually enters. So although here the behavior of both 3n-1 and 3n+1 is different. Also, we have the statistical comparison, a statistical property for n in -100 and -1. Property average cycle length for 3n+1 is 6.2, 3n-1 5.8. Maximum cycle length is 18. Maximum cycle length for 3n-1 is 13. Maximum cycle length is 2. Minimum cycle length is 2. And also minimum cycle length for 3n-1 is 3. Most common cycle is 5 cycle. For 3n-1 is 3 cycle. Convergence is very fast, average 8 SWs converged. Here is medium, average 12 SWs converged. Predictability for 3n+1, the predictability is low, but 3n-1, the predictability is high. Also, here is the convergence time for value from starting value from -1 to -20. Here is the number of steps to cycle. We can see that the growth of the starting value also grows the number of steps to enter to the cycle. And finally, key mathematical relationship. They are symmetry. The 3n+1 minus n approximately equals -3n-1n. They are symmetry. Invariance, but preserve at n congruent to 0 mod 2. Fixed point n-1 is fixed under both in different ways. Cycle structure cycle correspond to periodic fixed point. There are some open problems in this area. Are there infinitely many cycles for 3n+1 or negatives on negative number? Is the 3 cycle only attractor for 3n-1, or there are some unknown cycles? What is the relationship between cycle length and value of n? Can we find a general formula for all cycles? There are many open problems in this Collatz series. Connection to positive case, understanding negative cycles, then we can understand the Collatz Conjecture. Here's although the show the graph the computational result for n from -1 to -100. The number of for 3n+1, the red one shows the 3n+1 and the green one shows the 3n-1. The cycle type we can see for the 3n+1, the more than 40 goes to the 2 cycle, and then 5 cycle, and about 20, less than 20 goes to 18 cycle. For 3n-1, the most about 85 of numbers go to 3 cycles, and others goes to other cycles. 3n+1 is spread across multiple cycles. 3n-1 is strongly concentrated in 3 cycles. So conclusion, 3n+1 on negative create a rich chaotic structure with many cycles. Why is 3n-1 is a highly structured with a single dominant attractors? And finally, this summary of all presentation. Collatz on negative numbers. Key finding. 3n+1 on negatives create multiple cycle length to 518. 3n-1 on negative leads to a single cycle, but are bounded, no value escape to infinity. The behavior mirror the positive phase but with different dynamics. Also, Oliver's symmetry between positive and negative numbers. This is the important property. Show that the choice of -1 or +1 create different universes. Provide insight to the cycle structure. Here we can see the open question. Are there infinitely many negative cycles for 3n+1? This is one problem yet. Thanks for watching. See you next video.